Dear students, how are you all? Welcome you in my YouTube channel, Kavi Vinay Badhani. Last day I taught you about that the electric field lines or force lines and the electric field intensity due to a point charge and due to uniformly charged ring. Now today I am going to explain you the electric dipole, properties of electric force lines, electric dipole moment, electric field intensity due to an electric dipole. Now let's get started today's topic. Characteristic of electric force lines. These lines, the electric force lines are started from positive to negative. Number 2, these electric force lines can never intersect each other because there are two tangents can be drawn at the point, which explain that there will be two directions of the electric force lines, which is impossible in the case of the electric force lines. You can say electric force line can never intersect each other. Number 3, electric line of force leave or enter the charge surface normally. Means the electric line of force or the electric field lines can be enter or leave in a charge surface is normally. Enter or leave in a charge surface normally. Number 4, these electric lines of force are contract in length, which explain that the attraction between the opposite charge bodies. Or can say the unlike charges have the attraction. It shows that, it explains that the unlike charges have attraction. Unlike charges have attraction if these lines are contract in length. Number 5, the electric lines of force have a tendency to expand laterally, which explain that they tend to separate from each other. Means the direction of perpendicular of their length. This explain a repulsion between like charges. Repulsion between like charges. If the electric force lines are expand, if R means electric force lines expand laterally, in which these lines are separated from each other. In which separated from each other? In the repulsion, when the two charges are equal or same charges. Number 6, the electric lines of force cannot pass through a conductor. This means that electric field lines a conductor is 0. Now we discuss about that the electric dipole. As we know that dipole means two head, two pole or two ends. And A dipole have two ends, two head or two pole. Any of these. When we will discuss about that, the electric dipole, means if we have two charges, can say Q and Q, two equal and opposite charges. If you have in the case of electric dipole, if we have two equal and opposite charges separated at a small distance r, then it is called the electric dipole. Its direction from here to there, only electric dipole. But if we will discuss about that, the electric dipole moment, then how we define this? If we have two charges, two equal and opposite charges separated at a small distance 2l, then the direction of the dipole moment, electric dipole moment, from here to there, and the electric dipole moment is equal to the product of the any of the two charges and the product of the small distance of these two charges. Means that if we have two equal and opposite charges separated at a small distance 2l, then the product of the any of the charge in these and the product of the any one of the charges and the small distance 2l is called electric dipole moment. Its example is this: HCl, H2O, NH3, HBr, CH4, etc. These are the examples of electric dipole moment, which are separated at a small distance 2l in these two charges, between two charges. The product of these any one of these charges and the distance is called electric dipole moment. Here we have two charges, minus q and plus q charges. The total charge is 0. But if these are separated, these are placed in an electric field, then these are separated from each other in an electric field, and the product of these electric charges, any one of these, and the small distance 2l is called electric dipole moment. The electric field due to an electric dipole is not 0. Electric field due to an electric dipole is not 0 because of the charge is minus q2 plus q are separated some distance, and the resultant field due to the charge is not 0 because they separated from 2l distance. Can say the dipole moment, then in other words we can say that it is the measure of the strength of the electric dipole is called the electric dipole moment, or can say the dipole moment of electric is a vector whose magnitude is equal to the product of either charge and the length of the dipole. P equals to q into 2l. Its unit is coulomb meter. And the dimension formula of this P equals to q into 2l. Q equals to IT L. Then we indicate this LTA. The dimensional formula of the electric dipole moment is LTA, and the unit is coulomb meter, And the example of these electric dipole moment is HCl, H2O, NH3, SBr, CS4 and etc. Now the next topic is ideal or point dipole. It asks in the examination, suppose that 2A equals to 0. As we know that the definition of the electric dipole moment, 2L, or it is same. In some places, in some books we write this 2L, and in other books 2A. It is both are same. If 2A equals to 0 in this equation, then Q equals to infinitive. Then we say that the dipole moment is same, resulting dipole is called ideal or point dipole. Mean the dipole moment is same, resulting dipole is called, the dipole moment is same, the resulting dipole is called ideal or point dipole. Or a dipole is negligible in small in size. A dipole of negligibly small in size is called ideal or point dipole. And dipole field. If we define the dipole field, then we can say that a field produced by an electric dipole is called electric dipole field. A field is produced by an electric dipole is called dipole field. Now we can measure the electric field intensity in two ways. First, field intensity on the axial line of the dipole, and the second is field intensity on equatorial line of the dipole. There are two cases we can easily find the electric field intensity on the axial line of dipole and the equatorial line of dipole. If you have some